about a year ago, I made a video of myself stacking 32 Chinese chess pieces in a stack in a tower. One of the nice things about Chinese chess pieces when they're stacked like that is sometimes you can use one piece to knock out the bottom pieces, and the tower actually stays intact at least momentarily, right? Sometimes if you do it just right, it will actually stay, but at least you can get it to momentarily stand. And if you record it and watch it in slow motion, my camera records about 60 frames a second. It's always nice to see what's going on, right? I actually did a rough calculation on the coefficient of friction between the chess piece and the table. I was using this to demonstrate a physics concept. I do some tutoring of physics, and I use that as a demonstration. We slowed down the video and did some calculations. Obviously, there's also air resistance, but that was a good enough approximation, right? And we used the falling pieces to demonstrate what the air resistance might be. We weren't able to get that because the pieces didn't go anywhere near far enough for air resistance to kick in. But the fact that my camera can record 60 frames a second really helps with those calculations, right? Maybe at some point I'll make a bigger tower and we can calculate some of those coefficients even more accurately, right? Anyways, let's get going. Yeah, Rummikub is one of the first four-player games I ever attempted to program on the computer. Four-player games are a little bit trickier for AI compared to two-player games because of how the players could interact with each other, right? You would think that in some cases, two players could team up against another player, right? Yeah, this is not so bad. How many Rummikub pieces are there? Let's see. There's 13 times 8. And then the two jokers, right? What's 13 times 8? 24, 104, 106 pieces. And we're already up to, well, they do get exponentially trickier as we notice with the Chinese chess pieces. I don't think the sliding trick is going to work very easily with the Rummikub pieces. Okay, they do get trickier as they get taller. The nice thing is you could put a bunch of them together and then stack them on top, right? Kind of interesting now making this video today, May 11th, 2020. One of the first things they reopened after the quarantine was the constructions, right? So it's kind of interesting that I'm thinking about building Rummikub towers, right? Yeah, so every year I compete at a computer Olympiad where computers compete against each other. Computer programs compete each other in games like Rummikub, like chess, and like the others, right? I'm thinking maybe one year we'll have a tournament where we write AI robots that build towers like this and see which robot could get the tallest before it falls, right? I bet a robot could do a lot more than 32 chess pieces, right? I tried it with 64 one time, with two sets of Chinese chess. I think I got up to 40-something. I bet a computer could do the 64 if it could, especially if it could scan just how even everything is, right? It might depend on the environment, right? Of how flat your surface is, right? I've been in buildings where you could literally put a marble on the ground and it will roll to one side of the floor, right? It makes me wonder if you have a large enough complex, right? Let's say I'm not sure how big the White House is, right? But if you had a large enough complex, the curvature of the Earth might start to make a difference, right? Especially if you think of a very long bridge, right? Let's say you were trying to build a bridge over the Bering Strait. I wonder if that bridge would end up going underwater if it wasn't tall enough, just because of the curvature of the Earth, right? But on land, if you have a Capitol building or a White House and it's big enough, I wonder why it doesn't bend like in some way, right? Because of the curvature of the Earth. And then if you put a marble on the ground, it would sink to the middle of the building, right? Because that's probably the lowest point then, right? I wonder if there's any buildings that are big enough for that to happen, right? Yeah, so one thing I learned about in calculus is you can make a leaning tower. See, if you put a piece that's halfway hanging over a ledge, it will float, right? Well, if you put a piece that's a quarter of the way over the ledge and then another one that's halfway over the first piece, that will work too, right? And if you want to put three pieces, then how far can you extend that? I'll let you figure out the math. Well, it's 1/6 for the first piece, and then a quarter, and then a half. I might try that. I might try that to see how many I can get. I'll need a very precise ruler, though. The problem is that Rummikub pieces are not exactly uniform, right? There's a little bit of a hole where the number is, right? You need something that's much more uniform than that. And theoretically, you could get that to extend, because it's 1/2 plus a quarter plus a sixth plus an eighth, and the series diverges, right? There's a problem to that, though. It diverges very slowly. I'll let you write a computer program to figure that out. You could add tens of thousands, millions of terms, and it would still only get you maybe about that far. I'll let you figure that out. And depending on how thick your pieces is, eventually you'll get so high above the Earth that gravity will work a little bit differently, right? I guess if you built the tower over the equator, eventually your pieces would get so high they would be in geostationary orbit, and yet you probably won't even reach very far off the ledge, right? I'll let you figure that out. Alright, let's keep building. Actually, I'm doing this all with one hand. It might be easier with both hands, but I want to challenge myself, so be it. I wonder what would happen if you had a stack of Rummikub pieces stretching out into geostationary, and then the final piece was just held by the fact that it was in orbit, and then the rest of the pieces, well, I guess the pieces in between the ground and geo would probably fall out, right? I don't know. I'll let somebody who knows a little bit more physics than I do figure that out and leave a comment. Although, it'd be kind of hard to find a place where the weather was calm enough for you to do that, right? Especially if we're anywhere near the equator, right? Wow. That's a lot easier than I thought it would be. Because 32 Chinese chess pieces is tough enough. I mean, I've been playing Chinese chess all my life. I remember as a kid, lots of frustrating hours doing that. It was only very recently that I ever got 32 chess pieces to stack like that. I think my very first attempt that actually went through, I actually recorded it for YouTube. I gotta find the old video of myself doing that. Oh no. I'm gonna put the camera down for a second so I can use my left hand. Oh my god. So with one hand I got about that far. That's how many pieces are left now. Yeah, I am surprised there isn't a tournament for stacking pieces, especially Chinese chess. Right? Not too many people play Rummikub, right? I think Chinese chess has overtaken Western chess as the #1 board game in the world. I think Western chess, Chinese, and then shogi, I think, are the top 3 chess variants in the world. But I think Chinese chess overtook Western. not long ago. Because especially in the computer age, right? Computers are still behind humans in Chinese chess, so it's still kind of interesting to play against computers, right? Whoa! 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 See, I wonder where such a building, if it were to exist, right? Where would you put that? Would there have to be no wind? There have to be practically zero seismic activity, right? Even here in Seattle, we get a magnitude 1 earthquake quite regularly, right? You would never feel it, but if you were to look up if we had an earthquake, right? I think a magnitude 1 would quickly cause that to collapse, right? See, what would be interesting is if we could have one of the pieces be made of some material that could instantly explode, right? And when it does, it happens so quickly that the other pieces settle into place without the whole thing collapsing, right? See, I think it's bullshit. The conspiracy theories, uh, or how 9/11 happened, right, with the pancaking of the buildings. I like to think that there was some planning ahead of time, that if the buildings had suffered some kind of damage and they evacuated everybody, that the towers could peacefully go without affecting the entire Manhattan area, right? That's what I think what caused the towers to come down, right? There was probably a safety mechanism in there. Um, but I don't think they were planning for 9/11 to happen and then wired up the entire buildings, right? Okay, we're gonna have a 9/11 moment. But it'd be fun to watch anyhow. Oh, man, we didn't get that pancaking effect though. Thanks for watching.